Hello everyone and welcome. Today we're going to be talking about excess reagent. Now this is the last lesson in Unit 3 for us, as well for stoichiometry. So the last thing that we're going to be doing in this lesson is we're going to be calculating the excess reagent. And now if you remember your limiting reagent and excess reagent, your limiting reagent is the one that gets used up completely. Your excess reagent is what's left over. Okay, so once again, if we have two compounds and they're mixing, most likely one of the two compounds are going to be used up completely, and most times there's going to be a little bit left over of a different compound, one of the reactants. So what we're going to be doing in this last lesson is we're going to be figuring out how much of that excess reagent or that excess reactant was left over in the reaction. Okay, so that's what we're going to be doing in this last part here. So in order to do this, there's no formal lesson other than the fact that we have some questions that we can do and go through it to see it. So that's what we'll be doing in this video here. Okay, so once again, let's try question 1 here. Okay, and what we're actually going to be doing, just to give you a little bit of a heads up, we're going to swap 3 and 4. So what I mean by that is we're actually going to do 4 first, and then we'll do number 3. Okay, because number 1, number 2, and number 4 we've already seen. Number 3 is what's new to us. Okay, now next thing before we do start, during this lesson, at any time, if you want to pause it and try the question, I highly recommend you doing so. Okay, so for question 1 here, for example, write the balanced equation for the reaction that occurs when iron 2 chloride is mixed with sodium phosphate, forming iron 2 phosphate and sodium chloride. Well, I recommend you trying this out, pausing the video, trying it out, and then resuming it when you're ready to see what the answers are. Now, once again, you need to remember to always have your proper states as well as proper balancing. Okay, so let's go ahead and we're going to do this first here. Okay, so question 1, write the balanced equation for the reaction that occurs when iron 2 chloride is mixed with sodium phosphate. So, iron 2 is Fe2 plus, chlorine is 1 negative. So when these crisscross, you get FeCl2. Next, we have sodium phosphate. Sodium is a 1 plus, phosphate is a 3 negative, so we get Na3PO4. So these two are combining, and it seems like it's a standard double displacement, so we get iron, which is a 2 plus, phosphate's a 3 negative, so we get Fe3PO4. We put that all in a bracket with our 2. And lastly, we'll have sodium chloride, so that's just NaCl. Okay, so next we need to come up with our state. So this is where we look at our polyatomic ion sheet. So we would get aqueous. We get aqueous again. This one here is our solid, and this one's our aqueous. So because we're getting a solid and an aqueous, this is a precipitate reaction. So this reaction would happen. Now, lastly, we need to balance. So after I balance this here, I got 3, 2, and 6. Okay, so that's the first step. Now, once again, if you can't do this part here, you can't do the rest of the questions. So this is extremely important. Okay, so if 23 grams of iron 2 chloride reacts with 41 grams of sodium phosphate, what is the limiting reagent? How much sodium chloride can be formed? So let's go ahead and let's jump right on into this one. Once again, if you want to pause it, I recommend it so that you can try it out. Okay, so I'm just going to try and space out a little bit here. So for me, I'm just going to recopy what we have. Now, by now, you should have realized that this here is going to be a limiting reagent question. Now, how do I know this? Well, because I'm given 2 reactants. I'm given the mass here, which is 23 grams, and I'm given the mass here, which is 41 grams. Okay, now we're looking for how much sodium chloride. Now, in order to do that, we need to figure out our limiting reagent. So we do that by finding the moles of both. And we need to find the molar mass first to find our moles. We find our molar mass here to find our moles. Okay, once again, one common mistake, people will put 3 irons and 6 chlorines. That's not the case. It's only 1 and 2. 1 iron, 2 chlorines. So getting that mass, I got 126.75 grams per mole. So dividing these two, I took 4 decimals, 1815 moles. Okay, so next here we have 3 sodiums, 1 phosphorus, 4 oxygens. So that gives us 163.94 grams per mole. And to find our moles, we divide the 2 and we get 0.2501 moles. Now, which one do we use? Well, this is where we need to do our side work. Okay, so once again, I'm just going to go off to the side over here. Try to give myself plenty of room. Okay, one thing you need to remember is that we don't use any of the numbers in our side work. We're just trying to figure out our 1-to-1 mole ratio in order to see which one we're going to use when we're doing our mole ratios. So first thing I'm going to do is I'm going to take my moles here, 0.1815 moles. Okay, so that's this number here. And I'm going to divide it by the coefficient. So that's that 3. So I'm dividing by 3 to get my number. And I get 0.0605. Now the next one I need to do is the next one over. So I'm going to take 0.2501 moles. And I need to divide that, okay, that's 1.2501 moles, and divide it by the number in the front here, which is 2. And I get 0.12505. So out of both of these numbers, obviously this one here is smaller, so we're going to use this one here. So it's going to go from here all the way to here. Now, once again, we need to specify which one is the limiting reagent. So what I'm just going to do is I'm going to put LR here and ER there. If you do that on a test, I'll be able to figure out which one's your limiting and which one's your excess. So we have a 3-to-6 ratio. Now, can we reduce 3 and 6? Yeah, we can. We can go to a 1-to-2 ratio, which is the exact same thing. Okay, so instead of 3-to-6, we could bring it down to 1-to-2. Now, because it's a 1-to-2 ratio, this number here has to be 2 times bigger than that one there. So if I multiply this number by 2, I get 0.363 moles. Okay, so once again, what I'm doing is I have a 3-to-6 ratio. I can reduce that to 1-to-2. And by now, I know that 1-to-2 means that this number on this side has to be 2 times bigger than that. Now, if that doesn't make sense, or you're not understanding that, what you can do, okay, if I erase this 1-to-2, is we can make our fraction, right? We could go 0.1815 to x. We can set up our fraction. I'm just going to set it up here. 3 over this number is equal to 6 over x. And then you can cross multiply and solve for x. And when you solve for x, okay, once again, if you're not sure what I'm doing, if you go back to our mole ratios lesson, which was our first lesson for this last part here, you'll be able to see that. Okay, so anyways, x is 0.63, and that's where we get that moles there. So, in order to find our mass here, we need our molar mass of sodium chloride, which is 1 sodium, 1 chlorine, which is 58.44 grams per mole. And then to find our mass, we multiply these two numbers, and we get 21.21 grams. Okay, so once again, to get full marks, you would give me a therefore statement, and you say, therefore, we could make 21.21 grams of sodium chloride. Okay, so like I said, I'm going to jump down to question 4 here. Okay, and reason why is because we're dealing with percent yield. Okay, so if 16.1 grams of sodium chloride were formed, what was the percent yield? So in order to do that, we need 2 numbers. We needed our actual yield, and we need our theoretical. And to make it into a percentage, we multiply by 100. Now, our actual yield is the yield we got after doing the reaction. So after the reaction, we got 16.1 grams. Okay, it's 16.1 grams of sodium chloride were formed in the reaction. Now, what's our theoretical? What should we have gotten if we did it completely perfect? We should have gotten 21.21 grams. Okay, so we lost quite a bit of product along the way. So our percent yield is not going to be very close to 100 in this question. Okay, sorry, I just cut out there. Okay, so once again, 16.1 grams, and we're divided by 21.21 grams. Okay, because that's what we got theoretically. So what I'm going to do, sorry, I'm just going to try to move this to get everything in. Okay, so after dividing these two, once again, our units are going to cancel out, multiply by 100. And the number I got 75.91%. Okay, so about 75% of the product we got. Okay, and once again, obviously, we give you a therefore statement. Therefore, the percent yield for this reaction was 75.91%. Okay, so that's everything that we've done up to this point. Now we're going to add our last step. How much of the excess reagent remains when this reaction has gone to completion? So once again, as you can see, our limiting reagent is the one that gets used up completely. We are going to have some excess reagent left over. So what we're trying to figure out is how much was left over. Okay, now in order to do this question, we're actually going to have to rewrite this all out. Okay, so the whole reaction we have to write out. So what I'm going to do is I'm just going to flip to the back side as I have a little bit more room there to complete this question. Okay, so once again, what I'm going to do is I'm going to rewrite my equation out. Okay, make sure to have all our proper balancing. Okay, this is a 3 here. All right, so we have everything up there. Now, when we're doing our excess reagent, what you need to remember is one simple thing. Okay, we are going from, okay, and I would write this out. We're going from limiting reagent to excess reagent. Okay, so I would write that down. That's what you need to remember. Limiting reagent to excess reagent. Sorry, my writing's a bit messy, but once again, that's what we have here. Limiting reagent to excess reagent. So if you remember from our previous question, we found out that this iron 2 chloride was our limiting reagent. So what we're going to be doing is we're going from our limiting to our excess. So that's where our arrow is starting. That's where our arrow is finishing. Okay. So in order to do this, and what's nice about this question is that more than half of the work is actually already done for us. Okay. So if we're starting over here, we're going to use the same mass that we were given for our limiting reagent. Okay, so the mass that was given is the same one. It was 23 grams. And what we need to do is find our moles. Okay, and what we're going to be doing in this question is we're going to be working our way around and we're going to try and find the mass here. Now, you might be thinking, well, weren't we given the mass? Right? So if I flip over, yeah, we were given the mass. This is how much we had in this reaction. What we're doing right now with all this work, we're figuring out how much mass did we use. So out of that 41 grams that we had, right, once again, here's 41 grams. Out of this 41 grams, how much did we use? Did we use 30 grams of it, 20 grams of it, 39 grams of it? Right? Because once again, we're going to have some left over. So we're not going to use completely 41 grams. We're going to use slightly less. So what we're trying to figure out is how much did we use? Okay. So what's nice is in this question, 23 grams stays the same. So guess what? Our molar mass is going to stay the same. Our moles are going to stay the same. Okay. We're going to have a new mole to mole ratio. But guess what? Even on this side, we're going to have the same molar mass. So a lot of the work has been done for us. Okay, so let's go back and let's do this question here. So we're given this mass of 23 grams. We know that our molar mass is 126.75 grams per mole. And we know that we used this many moles or have this many moles. Okay, so once again, all these numbers are staying the same. Okay. Now for this here, we don't have to do limiting reagent because we're not trying to figure out which one we're using up. We already know this is our limiting. We already know this is our excess. So we don't have to do that. What we do need to do though, is we need to do our mole ratio. So this one's a 3:2. Okay, so it's about a 1.5 to a 1. Okay, so once again, what I'm gonna do is I'm gonna do the long way here because I may not be good at doing 1.5 to 1 ratio in my head. So let's go ahead. 3 over 0.185 is equal to 2 over x. I cross multiply, and I get 3 multiplied by x is equal to 2 by 1.15. Now, last thing I need to do is I need to move the 3 over. So I divide this side by 3 to cancel out, and I need to divide this side by 3. So x is going to be 2 multiplied by this number, and then once you get that number, divide it by 3. And I got 0.121 moles. So that's how many moles we used. Okay, once again, what we're trying to figure out is how much did we use up. So our molar mass, which is nice, hasn't changed. And once again, we can find our mass here, and our mass that we get is 19.84 grams. Okay, now this is what we used. Okay, I'm going to put this over here to help you out. Okay, this is the mass we used. We used 19.84 grams. The question's asking, how much do we have left over? So if you take a look, we started off with 41 grams and we used 19.84 grams. So how much would we have left over? Well, what we're going to do is we're going to subtract the mass used from total mass. Okay, so we're going to take our total mass, which is 41 grams, and we're going to subtract 19.84 grams. And what we're left over is 21.16 grams. This is how much we have left over. So therefore, the mass left over is 21.16 grams. Or you could say that the excess reagent that we have left over is 21.16. However you word it is fine, but as long as what you're saying means this here. Okay, so just to recap, when you're doing an excess reagent question, the easiest way is to restart it. Okay, so you recopy what you've had. Okay, you need to remember this here, limiting reagent to excess reagent. Okay, if you remember that, that'll help you out a lot. So all your mass, your molar mass, your moles are staying the same. This time it's a 3:2 ratio. You find your moles. The molar mass stays the same, so you don't even have to calculate any more molar mass, and you find your mass. Then the last step is this one here. You subtract your mass used from your total mass. So our total mass is 41 grams, and we're subtracting what we used. What we have left over is the mass left over. Okay, we're gonna try one more question. Okay, now this one isn't in the lesson, so I'm gonna write it out. Okay, so I recommend you writing it out as well. Okay, so let's go ahead and let's try out another question here. Okay. Okay, so I'm just gonna move this down a bit. So, one way to produce iodine is to mix sodium iodate, which is a solid, with hydrochloric acid. Now, sodium iodide and water are also produced. Okay, so if you can't read my writing, one way to produce iodine is to mix sodium iodate, which is a solid, with hydrochloric acid. Now, once again, by now you should be able to come up with the formula of hydrochloric acid. Sodium iodide and water are also produced. So, part A, or part 1, write a balance equation. Okay, so once again, I recommend you pausing the video and trying to come up with it. All right, so for this question here. Okay, so we have, let me see if I can find it. Okay, so I'll do this in pen just to come up with the equation anyway. Okay, so we have sodium, which is a 1+, iodate, which is a 1-, so we get NaIO3, and I said that that was a solid in the question. And we're going to be mixing, oh, I'm sorry, I put hydrochloric acid. Sorry, I made a mistake here. Hopefully maybe you noticed that. Okay, sorry, I'm going to be changing this. Just realized it in my work. Okay, sorry, this is supposed to be hydroiodic acid, okay? Hydroiodic acid. I apologize for that. Okay, hopefully you didn't just give up on the question. Hopefully you resumed it to see. Okay, so hydroiodic means that we have iodine. Okay, iodine is a 1-. Now, because it's an acid, we need to add hydrogens. How many hydrogens? Well, we're just going to add 1 to balance out that charge. We get Hi, and because it's an acid, it should be aqueous. Okay, so it says one way to produce iodine. So we're producing iodine. And once again, it's a diatomic molecule. It is a solid at room temperature. And we need sodium iodide. Sodium is a 1+, iodine's a 1-, so we get NaI. Okay, this here's an aqueous product. And we get water, H2O, which is a liquid. Okay, so sorry once again, I apologize for the hydrochloric. It should be a hydroiodic. But anyways, we get 6 here. We get a 3 there. And a 3 here to balance. Okay, so that's our balance equation. Once again, if you can't come up with this, you unfortunately can't do the question. All right, B. How many grams of iodine can be produced from the reaction of 16.4 grams of sodium iodate and 97.4 grams of hydroiodic acid. Okay, so once again, if you want to pause the video and try this out, I recommend that. Okay, so we have, I'm just going to put this in pen. Okay, so for this question, what are we given? How many grams of iodine? So this is what we're looking for. How many grams of iodine here? Now we have a reaction of 16.4 grams of sodium iodate, and we have 97.4 grams of hydroiodic acid. So once again, as you guys can probably already tell, we have 2 reactants. We need to figure out our limiting reagent, so we need to find the moles of both. So we need the molar mass here, the molar mass there, to find both of our moles, to find our limiting reagent and our excess reagent. Okay, so our molar mass for sodium iodate was 197.89 grams per mole. Finding moles, both your grams cancel out, and you're left with 0.0829 moles. So hydroiodic acid, at the same time, we have 127.91 grams per mole. Okay, once again, that's 1 hydrogen, 1 iodine. And finding our moles here, we get 0.7615 moles. Okay, now by looking at both of these, you might think this one is your excess reagent, but we can't tell for sure until we do our side work. Okay, now in order to do our side work, we need to take both of our moles and we need to divide by the coefficient. So we take this and we're dividing by 1. So obviously we get the same exact thing there. Okay, now for the second one, we're going to take 0.7615 moles and we're going to divide this by 6. Okay, so this is what's going to tell us which one's what. And after I did that, I got 0.1269 moles. So this one is still bigger. So this is my excess reagent. This is my limiting reagent. And once again, you need to specify that. Okay. So what that means is we're going to go from here to here. And this is going to be a 1:3 ratio. Okay, now once again, 1:3 means that this number on this side has to be 3 times bigger than that number. So if you take 0.0829 and multiply by 3, you get 0.2487 moles. Now, if you're still unsure about that, once again, all you need to do is just set up that fraction, 0.0829 to x. You can set up the fraction and solve, and I showed it on the previous question in this lesson. Okay, but anyways, if we keep moving on here, we have our molar mass of 2 iodines. Okay, iodine's pretty heavy, so we get 253.80. Okay, once again, always keep 2 decimals, grams per mole. And then we find our mass and we get 63.12 grams. So once again, this is our theoretical weight. Okay, this is what we should get in this reaction. Once again, always give me a therefore statement. I'm just going to put dots because once again, you should know by now. Okay, but once again, this is our theoretical yield. This is what we should be getting when we run this reaction. Okay, so let's go ahead and let's try part C. Okay, so part C. What would the percent yield be if 57.79 grams of iodine was produced? Okay, so what would the percent yield be if 57.79 grams of iodine was produced? Okay, so in order to do this, I'll do this one in pen just to kind of change colors here. So percent yield. And once again, feel free to pause the video and try it yourself, okay? I recommend that. Okay, so we have our actual yield divided by theoretical. And once again, because it's a percent, we need to multiply by 100. So our actual yield was 57.79 grams. That's what we got. Now, after this reaction, we got 63.12 grams. That's how much we got. Once again, that's from this previous question. Okay, that's 63.12 grams. And we got to multiply by 100 to get a percentage. Once again, the grams cancel out, and you get a percent yield of 91.56%. So this reaction was done fairly well. Okay, not too much human hair or anything like that. So that's a very good number. All right, part D. How much of the excess reagent was left over? All right, so once again, in order to do this question here, what we need to do is we need to redo this equation here. So we have sodium iodate, we have our hydroiodic acid, and we have our products Okay, so in order to do this question here, you need to remember one simple thing. We're going from our limiting reagent to our excess reagent. Okay. So we started off with 16.4 grams of our limiting reagent. Our molar mass stays the same. And our moles stay the same. Now this time we're going to a 1:6 ratio. So once again, what that means is that we're going from 1 to 6. So this number here needs to be 6 times bigger. So if I multiply by 6, I get 0.4974 moles. Once again, if you're confused, all you need to do is just set up this fraction and solve, and you'll get this number here. Now, our molar mass of hydriodic acid isn't changing. And now we can find a mass. Now, once again, what does this mass here represent? This is how much was used up. What we're trying to figure out is how much was left over. So what we need to do is we need to take the mass that was given in the question. So the mass that was given was this here. That's how much we had. We had 97.4 grams. So what we're going to do is we're going to take the mass that we had, 97.4 grams, and we're going to subtract from what we used. Now, if you forget which one goes first, an easy way to kind of remember is your final answer should always be positive. So you always want the bigger number coming first when subtracting. So that tells us, therefore, okay, once again, I'm not going to write it. You should know this though. Therefore, we have 33.78 grams of this excess reagent left over at the end of this reaction. Okay, so that's how we do excess reagent, and that's the final piece of our stoichiometry question for grade 11 anyways. In grade 12, we'll look at it a little bit more. Okay, so thank you for watching, and have a great day.